Hi, my name is Gwen, your presenter for today's lesson. One of our topic for today is about the early development of symbolic algebra. Before we jump into our main topic, let us first define what the word symbol and algebra means. Symbol or mathematical symbols. Mathematical symbols are used to perform various operations. The symbols make it easier to refer maths quantities. It is interesting to note that mathematics is completely based on numbers and symbols. The math symbols not only refer to different quantities, but also represent the relationship between two quantities. All mathematical symbols are mainly used to perform mathematical operations under various concepts. Since the first grade or some of us in preschool, we have been introduced to basic math symbols, especially the addition, subtraction, and equal sign. This is our very first basic symbols to learn in preschool. But did you know that these symbols were non-existent not until the 15th century? More of this will be discussed further below. Moving on, we have here algebra. Algebra is the branch of mathematics that helps in the representation of problems or situations in the form of mathematical expressions. It involves variables like x, y, z, and mathematical operations like addition, subtraction, multiplication, and division to form a meaningful mathematical expression. Now we are all familiar with algebra, as we have seen this equation as early as in our elementary years. We have here an example of a simple algebraic equation, 3x plus 4 equals 28. I think we are in grade 6 when we are taught how to identify an algebraic expression and equation. Here in this example, we have 3 as our coefficient, which is an integer that is written along with a variable or is multiplied with a variable. Hence, we have 3x. Next, we have the variable x. Variable is any letter that is either a known and unknown, which will be tackled few moments from now. Moving on, we have the operation addition, and lastly, the constants 4 and 28, or the constant numbers that has no variables alongside them. Now, this is just a little recollection of what symbols and algebra are. So much of that, let us now move forward to our main topic, which is the early development of symbolic algebra. A brief overview of the development of symbolic algebra. The development of algebra began in Egypt and Babylonia around 1700 BC. The very first way of doing mathematical equations was primarily written in the form of words that remained up to the 16th century. Greek mathematician Diophantus was one of the pioneers of syncopated algebra. In this stage of notation, some shorthand was used along with prose. Indian mathematicians developed a syncopated algebraic notation independently of Diophantus. Around 1500 AD, symbolic algebra began to develop. The process of the development of a standardized, efficient symbol system is illustrated by tracing the evolution of some common symbols, such as the symbols for equals, addition, and subtraction. To fully understand the development of symbolic algebra, let us take a look at the stages of symbolic algebra. There are 3 stages of symbolic algebra, namely rhetorical algebra, syncopated algebra, and symbolic algebra. Let us now define rhetorical algebra, the first stage of the development of symbolic algebra. Rhetorical algebra. Rhetorical algebra in which equations are written in full sentences. Rhetorical algebra was first developed by the ancient Babylonians and remained dominant up to the 16th century. Examples of rhetorical algebra can be found on Babylonian cuneiform clay tablets written in the sesagesimal-based 16-number system from about 1700 BC. Rhetorical algebra is the stage when algebra is written in full sentences without any use of mathematical symbols. The early Babylonian and Egypt algebra are both rhetorical. In this stage, symbols like addition or plus is written as and minus or subtraction is written as less. To understand further, let us take a look at the following example. Example, 10 and thing to be multiplied by thing less 10. Writing this in a symbolic form, we would have the said expression as 10 plus x multiplied by, multiplication is represented by parentheses, x minus 10. Converting it to modern form, we would have x plus 10 multiplied by x minus 10. And solving this would be as easy as using the FOIL method. X times x is x squared, x times negative 10 is negative 10x, 10 times x is 10x positive, 10 times negative 10 is negative 100. Canceling the two like terms, negative 10x and positive 10x will be 0, and so we will have the final answer x squared minus 100, or x squared negative 100. Now the question is, if the problem was written in full sentence, does it mean solving this equation is also written in full sentence? The answer is yes. In rhetorical stage, equations and solutions are all written in full sentences. As such, the problem 10 and thing to be multiplied by thing less 10 will have a solution such as, therefore, thing multiplied by thing is a square positive, and 10 by thing is 10 things positive, and minus 10 by thing is 10 things negative. You now remove the positive by the negative, then there only remains a square. Minus 10 multiplied by 10 is 100, to be subtracted from the square. This, therefore, altogether is a square less 100. Now that is a lot of words, but it does solve the given expression. Converting the written problem and solution in full symbolism, we would have 10 and thing to be multiplied by thing less 10. Solution: thing multiplied by thing is a square positive, and 10 by thing is 10 things positive, and minus 10 by thing is 10 things negative. You now remove the positive by the negative, then there only remains a square. Minus 10 multiplied by 10 is 100, to be subtracted from the square. This, therefore, altogether is a square less 100. That was much easier and simpler than the other one. For further understanding of rhetorical algebra, let us take a look at the given examples with their corresponding symbolic form. Example 1. 3 times a certain quantity has the same value as 1/2 the same quantity increased by 10. In symbols will be 3a equals 1/2 a plus 10, or 1/2 a plus 10 equals 3a. Next, example number 2, 781 and 5 things. In symbols will be 781 plus 5y, or 5y plus 781. Example number 3, 2 less than 6 things square and things. In symbols will be 2 minus 6z squared plus z, or negative 6z squared plus z plus 2. Mathematics is already hard, and I'm living in the modern world where word problems are easier because we can just use symbolic forms to solve it. But in this time, whoa, I could feel the hardships of those mathematicians writing a solution like the one we just had. Moving on to the next stage, the starting point of some symbols, syncopated algebra. Syncopated algebra. Syncopated algebra in which some symbolism is used but which does not contain all of the characteristics of symbolic algebra. Syncopated algebraic expression first appeared in Diophontos Arithmetica 3rd century AD, followed by Brahmagupta's Brahmashukta Siddhanta 7th century AD. Rhetorical algebra was the only algebra for several centuries, as the Diophontos of Alexander pioneered syncopated algebra. This next stage in algebra's development uses some shorthand or abbreviations. In most part of the world other than Greece and India, rhetorical algebra persisted for a longer period. For example, Western Europe used it until the 15th century. Diophantus of Alexandria. Diophantus wrote Arithmetica, a book that tremendously influenced algebra and number theory. The word arithmetic comes from the Greek word arithmetic, which is composed of the Greek words for number, arithmos, and for science, techne. The notation in Arithmetica helped move algebraic notation from rhetorical to syncopated, as well as influencing the evolution of some individual symbols. Diophantus had enough of writing algebraic notations that he had made shorthands for this very reason. I mean, anyone would also be frustrated to write a whole solution in full sentences, right? But since symbols was not really a thing back then, Diophantus had his hard times also creating these shorthands of his. For example of Diophantus' shorthand is this. This, as you can see, is much shorter and simpler rather than that of rhetorical form. This one over here is a complete translation of each symbol represented by this table. Note that there was no symbol for 0 in the time of Diophantus. As mentioned above, Diophantus was very much ahead of his time in trying to introduce an algebraic symbolism. Although there were sporadic attempts to do so from the time of Diophantus until the early years of the European Renaissance, no essential further progress was made until the 15th and 16th centuries. To understand better, let us define what each symbols represent. First, we have the uppercase kappa with a superscript gamma, means cube of unknown. Next to it is a lowercase zeta, represents an unknown, or what we know today as variable x. Next, we have the uppercase delta with a superscript gamma indicating square of unknown, or square. And uppercase mo with a small circle on top represents a constant number. Lowercase Greek letters such as beta, delta, gamma, and epsilon are used for numbers. The minus is represented by an uppercase lambda with an extra leg, and plus or addition is represented by the closeness of the symbols as such. And now if we divide these terms into two different sides, we have twice cube of unknown plus. Plus is represented by juxtapose, or the closeness of two terms, quadruple of unknown. Notice that this group of equation is positive. On the other side, separated by the minus sign, we have triple square of unknown plus 5 units. Important note, negative terms are grouped together after the minus symbol. That means triple square of unknown minus 5 units is negative. This one here is negative. Why? Because of the rule, which is all groups after the minus symbol are a negative terms. That means these terms right here are all negative. Now let us convert this syncopated form in rhetorical form, or the written in full sentence form. This one here is our syncopated form as we've tackled previously. In rhetorical form, this will be a first number is formed by taking twice the cube of a second number and the quadruple of the second less the triple of the square of the second number less 5. If we write this in a word-for-word basis in symbolic form, we would come up with 2x cubed plus 4x minus 3x squared minus 5. Notice here that after the minus symbol, everything that follows it is negative, which is one of the rules of Diophantus' syncopated algebra. In modern terminology, where we would write this accordingly, this is how it would look like. 2x cubed minus 3x squared plus 4x minus 5, following the word-for-word basis look but is written in an orderly manner. Next, we have the Hindu mathematicians. Hindu mathematicians also use the syncopation of algebra. Among others, Aryabhata and Brahmagupta, to name a few, used similar forms of syncopation as of Diophantus. As you can see in this table, where they also use juxtaposition as a symbol of addition. The other symbols are their own shorthands. Examples of both Diophantus and Hindu mathematicians' syncopated algebra. Well, this stage is not that bad. I mean, we don't have to write equations and expression in full sentences now. That's a good relief. Moving forward, we have the period AD 1450 and about AD 1650. During this time, various mathematicians devised shorthands or abbreviations that were progressing from the syncopated stage to the symbolic one until by the mid-1600s, when we finally have a system of writing algebra that would be recognizable today. Symbolic algebra. Symbolic algebra, in which full symbolism is used. Early steps toward this can be seen in the work of several Islamic mathematicians such as Ibn al-Bana, 13th to 14th centuries, and Al-Khalasadi, 15th century, although fully symbolic algebra was developed by François Viatet in 16th century. Symbolic algebra initially used symbols. Over time, the symbols became more usable and more standardized. Symbolic algebra began to develop around 1500, but did not fully replace rhetorical and syncopated algebra until the 17th century. As mathematicians strive for compact and efficient notation, symbols evolve many times. Now let us see who and how these various mathematicians developed the symbolic algebra in modern terminology by developing the same expression through time. From 1400 AD, certain words or phrases are used as symbols. Our first mathematician is Johannes Müller von Königsberg, born on June 6, 1436 and died on July 6, 1476. Better known as Regiomontanus, was a mathematician who authored the De Triangulis. He was an important mathematician of his time. An example from 1464 is 3 census et 6 tempus 5 rebus equator 0. Or we can read this in modern terminology as 3x squared plus 6 minus 5x equals 0. Let us take note what these unknown words are. Census means square of unknown. It means plus or addition. Demptus means less, minus or negative. Rebus means thing or variable 1. And equator means equals. Next, we have Fra Luca Bartolomeo di Pacioli, sometimes Pacioli or Paciolo, born in 1447 and died on June 19, 1517. He was an Italian mathematician who with his Somma di Arithmetica in 1494 wrote the same equation as of Regiomontanus in a different way as 3cp6m 5 rebus a 0. In here, the unknown words are shortened and some are replaced by new symbols, such as C is a shorter word for census, here which means square of unknown. P or pew means plus or addition, M for minus, rebus means thing or variable 1, and A or equator means equals. The birth of plus and minus sign. The first use of the plus sign was in 1489 by German mathematician Johannes Widmann. The plus sign just represents the letter T, which was a short form of the Latin word et, which means and. Likewise, Widmann was the first person to use the minus sign as well. The minus sign is believed to come from a tilde, which was sometimes placed over a number to represent subtraction. Next, we have Robert Recorde, born on 1512, died on 1558. He was a Welsh physician and mathematician. Robert Recorde is known to be the father of the sign equal, as he used the equality symbol for the first time in 1557 in his algebra book, The Wheatstone of Wit, which he created from a pair of equal parallel line segments. He also introduced the pre-existing plus and minus sign to English speakers in 1557. Simon Stevin, born in 1548 and died in 1620, sometimes called Stevinus. He was a Flemish mathematician in Flanders, and in 1585 he wrote the same expression as 3 to the power of 2 minus 5 to the power of 1 plus 6 constant equals 0. Unlike the first two mathematicians that we tackled previously, Stevinus here wrote the square as number 2 inside a circle, exponent 1 or the rebus as number 1, and wrote a middle dot signifying 6 as a constant term. He used the plus and equal sign here and also used the minus sign, which was created by Ricordi in 1557 and by Johannes Widman. Moving on to the man who created a new look to algebraic notation, to the man who created the first symbolic algebra. In 1591, François Vieutet was the first person to use letters for unknowns and constants in algebraic equations. He used vowels for unknowns and consonants for given numbers, all capital letters. In Artem Analyticiam Astrologiae, he is known as the creator of first symbolic algebra. In 1591 in France, François Vieutet Seigneur de la Brigotière, born on 1540 and died on February 23, 1603, was a French mathematician whose work on new algebra was an important step towards modern algebra, due to its innovative use of letters as variable in equations. He wrote the same expression as 3na quad minus 5na plano plus 6 equator 0. François Vieutet was a French mathematician who did math as his part-time hobby, created a new phase for algebra that is widely used today. François Vieutet's innovation toward new algebra gave a huge impact to our modern symbolic algebra. For example, the way he wrote the same equation is written in an orderly manner. As if we convert this expression literally, we would come up with 3a squared minus 5a plus 6 equals 0. This expression is now how we would write it in today's mathematical form. Note that quad or quadratus in Latin means square, plano means plane or exponent 1, and as we all can remember, equator means equals. Unfortunately for him, he was not familiar with the sign equal, even though the equal sign was widely known by his time, thus resulting for him to use equator to represent equals. Vieutet gave algebra a foundation as strong as that of geometry. He then ended the algebra of procedures, creating the first symbolic algebra, and claiming that with it, all problems could be solved. He was known as the first to create the first symbolic algebra by using vowels for unknowns and consonants for known quantities. For example, a cubus plus c plano and a equator d. Plus and minus signs were used for addition and subtraction, and a fraction line for division. However, he still wrote the word in for multiplication and equator instead of the equal sign. Note that cubus is cube, plano is exponent 1, and equator is equals. A is a vowel that makes this an unknown variable. C is a consonant. This means this is a known variable. With the unknown variable a, exponent 1 equals to d, which is a known variable. If we write this in a symbolic form, we would come up with a cubed plus ca equals d. We must always remember Vieutet's rules, which is all variables or quantities must be in capital letter. If we convert this in modern terminology, we would come up with this one. In using a to denote the unknown quantity x, Vieutet employed a quadratus as today's x squared and a cubus as x cubed. This innovation considered one of the most significant advances in the history of mathematics, which prepared the way for the development of symbolic algebra. René Descartes, born on March 31, 1596, and died on February 11, 1650. He was a French philosopher, mathematician, among many others. Descartes also wrote the same equation in 1637, the year of his Discours de la Méthode, as 3x squared minus 5x plus 6 equals 0. Unlike Vitae's variable where vowels represent unknown quantities and consonants represent known quantities, Descartes used the letters near the beginning of the alphabet to represent the known quantities, while letters near the end represent unknown quantities. Let us now look at the evolution of symbolic algebra through the various mathematicians whom we were just discussing about. The equation we are looking here is all the same but went through different timeline. We use Regiomontanus equation, 3 sensus et 6 demptes 5 rebus equator 0. In Paschal's time, he used some of Regiomontanus' phrases but made it much shorter, hence writing it as 3 cq 6 d 5 rebus a 0. By the time of Stevinus, he did not use phrases here but wrote it in numbers. For example, the square is written as 2, the exponent 1 is written as 1, and wrote a middle dot signifying 6 as the constant term, which reads as 3 to the power of 2 minus 5 to the power of 1 plus 6 constant equals 0. Next, we have Vitae's version, where he used the first variable known as capital letter A and wrote it with coefficients and the whole equation in a fully symbolic form. He wrote it as 3 quad minus 5 plano plus 6 equals 0. Quad represents square and plano represents exponent or to the power of 1. And finally, the version which all of us are very familiar with, as this is how we write algebraic equation and expression. Descartes' version, where he wrote it as 3x squared minus 5x plus 6 equals 0. This brief summary of the history of algebra and some of the most commonly used symbols shows that it took mankind's finest mathematicians many years to develop a compact, efficient symbolic algebra. Learning to use the algebraic symbol system is a challenge for good reason. The origins of some commonly used symbols provides interesting glimpse into mathematics that is an evolving human endeavor, rather than the compact and highly abstract presentation of most textbooks. Seeing that mankind struggled for 3,000 years to produce it may encourage students to persist a little longer in their attempts to understand it. From rhetorical algebra syncopated to today's symbolic algebra, that was one huge evolution of algebraic notation. Knowing so much of this, aren't we thankful that François Vitae came up with a new look and for René Descartes for making it way simpler? Yet, many of us still find it hard to write and understand algebraic notations. Well, that's math. So much of that. Thank you for listening and watching this brief video about the early development of symbolic algebra. I hope you had a better understanding about symbolic algebra. Once again, my name is Gwyneth Rose Ontalan from BSEdM 1A. Merci et la prochaine. Thank you and see you next time.